Today we're going to go over frequency distribution tables. Let me set up the problem for you. Some residents, they claim that people are speeding through the neighborhood. The police set up a radar detector between the times of 2 o'clock p.m. and 6 o'clock p.m. They measure the speed of vehicles traveling through. The following table shows the results of the data collected. So what we do in a frequency distribution table is we set up what we call classes. Now, classes represent things that are essentially the same. In other words, somebody driving between 6 and 10 miles per hour, they're 6 miles per hour, pretty slow. 10 miles per hour, still pretty slow. 10 miles per hour to 15 miles per hour, yeah, they're all about the same. Between 16 and 20 miles per hour, again, about the same. So we classify this class or the speeds driven into one class. Now the frequency tells me how many cars in this case were driving by between and including these two speeds. In other words, there were 3 cars traveling somewhere between 6 and 10 miles per hour. There were 8 cars traveling somewhere between 11 and 15 miles per hour, and so on. So you'll be asked to determine the mean, the variance, and the standard deviation for each of these grouped data sets. Okay, so here we have the formula for the mean. And right now, this formula won't make any sense to you. What we're going to do is we're going to set up a column called X with a little m next to it. We call that the class midpoint. And we're going to take it from there, and I'll explain all this when we're in spreadsheet mode. This represents a sample variance. We assume we have sample data here. And this sample variance is a pretty long formula. And there's actually no real easy way of doing this, so I will show this to you on a spreadsheet as well. And here we have the standard deviation of this grouped data, and I will show you how to get this. It's essentially the square root of the variance. So we have mean, S with the 2 next to it is variance, and S is the standard deviation. So let's get to it. We'll go to spreadsheet mode. Here we are in spreadsheet mode. And the way I have this spreadsheet set up is it's asking you a question, first of all. What are the number of classes that we have? Well, right now it just says 3, but we actually have, let's see, 1 class, 2, 3, 4, 5, 6, 7, 8, 9 classes. So I'm going to just type in the number 9. The next thing that we need to do is calculate this thing that we call the class width. And this will help us with a few other things that we're going to do, at least do behind the scenes. But we'll let the spreadsheet program do this for us. Now let me explain to you what the class width is. A lot of students make the mistake of taking something from an upper class and subtracting the lower class limit. So a lot of students might think it's 10 minus 6, but in reality, it is not that. The class width is actually, instead of 10 minus 6, which would give us 4, it's 11 minus 6. We would take any, say, lower class limit and subtract the one that comes before it. And they should all be the same. In other words, 11 minus 6 is 5. 16 minus 11 is 5. 21 minus 16 is 5. 26 minus 21 is 5, etc. By the way, you can also do the same thing for the upper class limit. In other words, 15 minus 10 is 5, 20 minus 15 is 5, and so on. We'll let the spreadsheet do this just from dealing with the first two classes, and I'll use the lower limit. It's a very simple thing. It's just a subtraction thing. So we'll just type in equals. We'll click on the cell that contains that lower class limit for the second class, which happens to be 11, minus the one that comes before it. And I'll press enter. It automatically calculated that as 5. This is the same table from the problem that I posed. And again, we just label these things lower class limit or upper class limit. Those are just the general things that we call them. By the way, this down here are what we call the class boundaries. You'll be asked to list the class boundaries on some of your assignments. So I'll just let you know the class boundaries fall between classes, or between class limits, I should say. So 10.5, for example, falls between 10, the upper class limit of the first class, and 11, the lower class limit of the second class. So that's basically all the class boundaries are, except for the first one and the last one. The first one will just fall the same number of units away to the left of this and same units away to the right. In other words, this is 5.5 and this is 50.5. Half above that and half below that. So you'll be asked to list that out on some of your assignments, and it will end up being just a comma-separated list. Next, let's talk about this column. We call this column the class midpoint. It's a very easy calculation. To calculate the class midpoint, what we're going to do is type in an equal sign, and the formula is just halfway between the lower class limit and upper class limit. It's sort of like the same formula you use to find the midpoint of on a line or something if you took an algebra class. You just take the lower number plus the higher number, you add them up, and you divide by 2. So this is going to equal this 6 plus that 10. I'm going to close parenthesis, divided by 2, enter. And now, if I grab this and drag and drop, and those were dynamic cell references. In other words, I want them to update as I drag and drop down. So let's do that, and you'll see that this represents all the class midpoints. In other words, 6 plus 10 is 16, divided by 2 is 8. 11 plus 15 is 26, divided by 2 is 13. Now, in this column, what I want to do is I want to multiply each frequency times each class midpoint. And by the way, back in the day, what we call this column has changed. We now call it the class midpoint. I used to call it the class mark. That's how I was taught. And we could also call it the class median. It doesn't really matter. Just know that we have different names for this, and different books or journals might call it something slightly different. Okay, so in this column, we take each frequency and we multiply it by the class midpoint for that class. So it will equal this 3 times that 8, and I'm going to press enter. And now I'm going to just drag and drop all of that down. And this gives me the frequency times the class mark. Let me try to explain this in a little bit more detail. The class midpoint represents basically every number we have between 6 and 10. In other words, we're saying, all right, well, somebody going 6 miles per hour, 10 miles per hour, we'll just call it 8 miles per hour. And by the way, we have 3 of those. Same thing for this. Anything between 11 and 15 miles per hour, we'll just call that 13 miles per hour. It just makes tabulations easier. Now, why do we do this? Why do we take each frequency and multiply it times the class midpoint? Quite simply, it's this. I have what this shows right here. If I didn't know what these first 2 columns were, this would be saying I have 3 8s. Or in other words, if I were to calculate the mean, that would be 8 plus 8 plus 8. Or 3 times 8. Either way, you would get 24. This is saying I have 8 13s. So if I wanted to continue to calculate the mean of all of my values, I would have 13 plus 13 plus 13 plus 13 plus 13, well, whatever, 8 times. Or I can just say 8 times 13 and get that. Now, let's calculate the mean first. The mean is simply you add up all your values and divide by the number of values that you have. Well, let's first figure out how many values we have. The number of values that I have are actually just the sum of all the frequencies. In other words, I have 3 of something, 8 of something, 11 of something, 25 of something. But when I add all this up, that gives me the total number of values. So just someplace down here, I'm going to say num of values equals, and let's see, and equals, we'll use that old sum formula. And I'll grab the first one, I'll go down to there, close my parentheses, press enter. So that means that I have 125 total values. In other words, during that day, a total of 125 cars went through that particular suburban neighborhood during the times, I think I said between 2 p.m. and 6 p.m. Okay, so the next thing I want to do is add up the sum of all my values. Well, remember, we're using 8 to estimate everything between 6 and 10 miles per hour and 13, etc. Now, this represents all of the 8s I have. This represents all of the 13s that I have. This represents all of the 18s that I have. But if I add all that up, it will give me the sum of all my values, an estimate of that. So I'm going to say sum equals, just to label the cell next to it. Let's make that a little bit prettier here. Okay. equals sum, open parenthesis, and grab all of these. And I'm going down a little bit further than I have to. It just discounts these cells if there's nothing there. I'm going to close parentheses, press enter, and we have 3395. You all know that in order to calculate the mean of something is you add up all your values and you divide by the total number of values you have. So we can say, and let's see, I'll just put it right here, mean equals, and let's make that a little bit nicer just to line up with everything else that we have. So mean equals, so it's going to equal whatever I have in this cell divided by whatever I have in that cell. And I'm going to press enter. So my mean is 27.16. So what that means is what it sounds like, that on average, the speed that people are traveling through this particular neighborhood works out to be about 27, a little more than 27 miles per hour, which is speeding. And we would have to determine whether or not that's, it's worth starting a whole ticket campaign to slow drivers down if the average is 27.16 miles per hour. Now, obviously, these people who are going much faster than that, they all deserve tickets, but it costs money to post a police officer in one place to ticket people or to make sure they slow down. Or maybe this is even a survey done to see if some sort of speed bump should be put into place on the taxpayer's dime. And would it be worth it? And that just depends upon how you want to interpret this information. I am going to talk about finding the standard deviation and variance in my next video, as I am running out of time on this video. So have a great day.